Hello everybody, welcome back to the shop. Today we got a little tip or trick for you on how to get out a broken bolt or nut with a MIG welder. So today we're going to use a MIG welder to get out a broken nut or bolt out of a couple of castings that I'm trying to repair here in the shop. Today the MIG welder we're going to use is the Power MIG 210MP. Now this is my go-to welder here in the shop for a lot of reasons. One, it's a multi-input voltage machine. It means I can run it from 110 or 220 without any tools. It switches very easily. It'll also MIG weld, which is its primary function. It's a really good stick welder, and it also has the ability to do DC lift start TIG. It's a really compact little machine that I can just grab it to do a lot of these small shop projects here with a lot of power pack behind it. So what we have here are a couple of castings from a rotary vane fuel pump that I'm trying to repair. It's a pretty expensive pump. I've got an aluminum casting for the electric motor. I've got a cast iron or cast steel casting for the actual pump volute itself. Taking this thing apart, did everything I could, tried to be as careful as I could, worked the bolts back and forth, gave it a lot of knocker loose, trying to get it loose, but this is the head of the bolt and it just twisted right off, which left us the stud behind. The state of corrosion was just horrible here. In the aluminum, I've got one broken off here, one broken off here. In the casting, in the flange, I've got 4 broken off in the flange. Now those of you that are already shop guys or do-it-yourselfers, you know the first thing you do when you snap those bolts off is go to the toolbox and you grab what? The vice grips of death. Right? You grab the vice grips, you tighten the screw down as tight as you can get it, and then you squeeze it as hard as you can. You try to get that bolt out. What winds up happening most of the time is you booger it so bad the vice grips won't hang on to it, or you shear the bolt off flush with the casting. That results in having to drill it and rethread it, or try to use an easy out type extractor set to get it out of here. I don't think I'm going to have a lot of success with an easy out extractor set for several reasons. There's a lot of corrosion down here. This little trick, I've learned it over the years. It's worked more times than not for me, so I want to just pass it on to you and hopefully you'll be able to use it. I've got 4 studs here in the pump casting that are sticking out at different depths. Ironically, they all broke off differently. I've got one in the aluminum, and then I've got one in the aluminum here that's broke off flush. This one's going to be a booger bear. I've got just a little bit of material sticking up. So here's how we're going to use the MIG welder to get this out. Go to your bin. You know that bin you have in the corner shop. Sometimes it's a coffee can, sometimes it's a 5-gallon bucket, sometimes it's a glass mayonnaise jar, sometimes it's a pickle jar that still smells like dill pickles, but whatever. You've got that full of rusty nuts and bolts. Most of you guys have probably been questioned a time or two, sometimes by the wife, why do you keep that bucket of old nasty nuts and bolts around? Throw that crap out, get it out of the garage, and you just can't leave yourself to get rid of it because you know how valuable it is when you really need it. Well, go to that nut and bolt bin and get yourself a couple of rusty, crusty nuts. Now, here's a little tip. You're going to weld on these, and these things a lot of times out of that bin are nasty greasy. So you're going to have to degrease it, get the schmoo off it, use some type of solvent to get them good and clean, no rust in the threads. Now, these particular bolts here are 1/4-20. I can screw a 1/4-inch bolt on here, put it all the way down on there, weld the head of it, and try to take it off. That may work. There's another option though. If we take an oversized nut and we set it on there, gives us a little more time to get in there and fill, which gives us a little more heat. The heat from the MIG welder is what's going to be that catalyst that's going to help us out. That heat is going to get down and help loosen the threads that are stuck, because as you guys know, a lot of times when we have a stuck nut or bolt, one of the things we always do is take the torch, put a little heat on it to try to get it to loosen up. So one of the problems with this nut is it's square across the top, and a lot of times we have just a little tiny piece of stud sticking up. Not enough to even stick up past the top of the nut. But we want to be able to get down there and weld on it. And one of the things we want to do is we want to give that welding machine enough time to do the good penetration we need, but also drive the heat down in the center of these bolts to allow it to start to loosen up. So one of the things we can do is take this nut and open it up for us. We're not going to ever reuse it again as a nut. And how we'll do this is with a countersink. And if you're not familiar, a countersink is for putting a tapered hole in metal for like a countersunk screw, or relieving the edges to get a burr off them. We now have a nice chamfer that runs down the side. It's nice and deep down into the material. All right, folks, here we go. We are set up on the bench. A couple little housekeeping things I want to talk to you about real quick. Workbench is grounded, so the grounding clamp for the welding machine is tied to the workbench. A couple little things I want to do here. We're all safety geared up. Real important with MIG welding, because if you've ever gotten one of those hot weld buggers down your britches before or down your back of your neck, you can dance like Michael Jackson. Let's go to this cast iron part. I have this device now clamped to the workbench. We put a 5/16 nut over the 1/4 stud. So this is just a little Bernzomatic style, MAP gas propane torch. I'm gonna put a little heat in here. Not a lot, a little bit of heat for a couple reasons. The science behind this is the MIG welder creates a short. We're using short circuit MIG welding, which creates heat, causes the wire to pinch off and fuse to the base metal. It takes energy to do that. What we're looking for is a good weld, but we're also looking for the heat. If I can take this piece and say bring it to 350, maybe 400 degrees, just right here on this corner, it takes less energy for the welder to bring the part up to temperature. That gives me more energy to drive or heat into the weld for penetration. Got a bolt around it. It's clamped to the workbench. Workbench is grounded. Machine is set up. We're running shielded gas right now. 75% argon, 25% CO2. We're running an 025 wire. And get right down in there. Run it right in the bottom. Let's give her a go. Still got a little cherry red in it. I'm just waiting for it to cool down.
It's intermission time, folks. So hurry, hurry, hurry. Step right over to our refreshment center for the most extravagant array of refreshment goodies ever assembled under one roof. And now, on with the show.
Will it let go for us? So I think we're making progress because it's starting to tighten back up on me. So let's give it a little motivation. All right. And just like that. All right, so we've got 1 out of the 4 out. Let's keep going. All right. Well, we've gotten 4 of those stuck studs out. That's great. That's good news. Real gently, I've taken this pair of vice grips and I've pulled the wires as far away from this corner as I can. These feel like pretty high-end wires. I don't think they're silicone, but I do think they'll take the heat pretty well. You can tell you're starting to get above 200 degrees is you'll see the water vapor on it start to push out of the porous material. You can actually see it, so you know that the part's reaching 212 degrees. One of the properties of aluminum is aluminum has a very high thermal conductivity, meaning aluminum loves to transfer heat. So as we heat this part and start to warm it up, what it's doing is transferring the heat over here, getting rid of it, which everyone thinks makes aluminum hard to weld. It's not. That's not the case. It just properties are different than steel. And once we learn to deal with those properties, it's not hard to weld. Okay, gotta go quick here. We don't want to lose our heat. I'm gonna center this bad boy up right there. So it looks like the stud actually did weld on. I can see a piece of the material where it sheared it off the top here. Not a whole lot more we can do with that one because it was so short. I hope this information you find useful. I hope you're able to use it in your shop. Remember that, you know, always wear your safety stuff when you're doing this. These parts are hot. Fortunately, we weren't able to get all of them out. We were a little better than about a 60% success rate. These two here are gonna wind up getting milled out of there. The takeaway here for me that I learned from this, because I always am learning too, is I was probably a little afraid of the wires and the epoxy seal in here. Probably didn't put quite enough heat into this. And here's why I think that. There's paint from when this object was painted. I blasted it in the blast cabinet and the paint is still on here. Didn't put probably enough heat into this to cause it to let go before we broke them off. We're gonna just have to center punch them, drill them, and rethread them. Out of having to do that 6 times, I narrowed it down to where I only have to do it 2 times. If you don't have a MIG machine, TIG works really well for this too. And if you fall back and you don't have either one of those, the old AC buzz box, if you're pretty talented with a small rod, you can make that work too. I've had to do that before on actually some bigger bolts that we had broken off or actually rusted off when I was doing some work over in the islands and I didn't have a MIG machine or a TIG machine with me. Was able to take the old AC 225 Lincoln buzz box and hit it with a 332 rod and weld them right up and get them right out. Folks, I hope you found this little shop tidbit of information helpful. You know, if you like what you saw here, subscribe to the channel down below. Please give me a thumbs up. That helps us be able to keep making these videos. Also, you can follow me on Instagram under Do Right Builder or on the Do Right Fabrication Facebook page. Thanks for watching. We'll see you again real soon.